Okay, so today we're doing piecewise functions, and we're going to start by just reviewing how we can tell what a function is going to look like just by looking at the equation. And if you'll recall, on A we have a degree of 1, and we know from when we did polynomials that that makes it a linear equation. And linear equations are simply just straight lines. On B, we have a degree of 2, and we know that those are quadratic. And what we know about quadratic equations is that they're parabolas. So they're going to open up or they're going to open down, but they're parabolas. So if we see an x squared, if our degree is 2, we know that we're going to have a quadratic. Here, where our exponent is our variable, that's an exponential function. Okay, and that's where the graph comes down and meets an asymptote. Well, it doesn't meet it, but it approaches the asymptote. It could be like that, or it can go from the asymptote and up. All right, so that's exponential. Here, don't let the fraction throw you off. My degree is still 1, so this is also linear. And on E, my degree is 2. It's okay that I don't have a B term. The highest exponent I have is 2, so that's still a quadratic, which means it opens up or down. So you should have a good idea of what your graph should look like just before you graph anything, just by looking at the equation. So let's put that to use here. Okay, we're going to do piecewise functions. It's a function that's defined on a sequence of intervals. There's some steps for doing the piecewise function. I'm not going to go through those steps one by one. What I'm going to do is just apply them by working through the problems. And we're going to start with this first one. We have two equations here. This is the first equation. So this is what it's like: y equals, or f of x equals 2x plus 3. And these are my domain restrictions. These are domain restrictions. And what that tells you is, for instance, for this first one, I can only have this first graph to the left of -1. And so this isn't part of the function. I just put these in here as visuals that are like walls. Okay, so if this wall is at -1, this function can only be on this side of -1. Okay, so that teal function can only be on this side. So when I pick numbers, the first thing I pick is that whatever that first restriction is, and then my remaining points that I'm going to pick for my table are going to be to the left of -1. So -2, -3, and -4. We look at the inequality for a couple of things. One, again, which side are our points on? These are to the left. And it also tells you if that first point is an open or closed circle. And because I don't have the equal sign underneath there, that means it's an open circle. And you take this and you're going to plug it into the equation. So 2 times -1 is -2, plus 3 is 1. 2 times -2 is -4. -4 plus 3 is -1. 2 times -3 is -6. -6 plus 3 is -3. And 2 times -4 is -8. -8 plus 3 is -5. Okay, so, and we know that this is linear because I have a degree of 1. So I know it's going to be a straight line. So I have -1 and up 1. That first point is an open circle. And that's the only place you're going to have the open circles, on that first point. And then I have -2, -1, -3, -3, and -4, -5. So this is going out to the left. Notice this wall that we created, it does, where that open circle is, it does not continue up to the right because the values are only to the left according to our domain restriction. Okay, so for this next one, this is a quadratic function, so we know that it's going to be a parabola. Whenever you have a quadratic function, you need to find your vertex. And the way we find our vertex, the x of our vertex is -b over 2a. So my b is -6. The opposite of -6 is +6 over 2 times my a, which is 1, right? Because A is the coefficient of the squared term, B is the number in front of your x term, and C is your constant. So 6 over 2 is 3. So the x of my vertex is 3. And then you plug that into the equation. So I have 3 squared is 9. Minus 6 times 3 is minus 18. That's negative 9 plus 2 is negative 7. You're just plugging it into the equation. So that I know that that's my vertex. For my points in my chart, I'm starting at negative 1. But this time I'm only picking points to the right of negative 1. So I would go with 0, 1, and 2. And my first point is a closed circle because I have an inequality underneath it. So if I plug in negative 1 to that equation, I'm not going to go through and show you how to plug it in. You should know how to do that. Just make sure that you do your squaring before you do any multiplying. But this should be 9, 2, negative 3, and negative 6. And I'm just going ahead with those because for the sake of time, I want to focus on the piecewise part. So I have negative 1 and up 9, and this is a closed circle. 0, 2, 1, negative 3, 2, negative 6. Okay, so it looks like it's starting to curve. It's a parabola, so I know it's got a curve. You've got to plug that vertex. So that's 3, negative 7, and then it's going to turn around and mirror it and come up this way. Okay, all these points are just mirrored. And when I go to graph it, I start here. It does not go up past this wall. It starts at this wall and then goes down and down around my vertex and then back up. And that arrow does go out to the right. Okay, it's not the straightest, prettiest, but you get my main idea there. Why is it curving? That's kind of weird. I digress, I know, but that's just weird. Okay, more like that. Right, notice neither one of them goes past that firewall, is what I like to call it. It's like a big roadblock to your graphing. Okay, so let's try another one. Okay, we're going to do linear quadratic. Okay, we're telling you that is, but I shouldn't have to tell you what it is. You should be able to tell just by looking at the equation. So I know this first one. I've got y equals 4x minus 3. Okay, I know it's linear because my degree is 1. I know my first point is going to be at 1, and it's going to go to the right of 1, so that my points are going to be 2, 3, and 4, because those are to the right. And I know that this first point is a closed circle. Okay, and I have a firewall at 1, so I'm just going to... Okay, you do not have to draw that wall in. I just think it helps visually. It's not part of the actual answer. It's just kind of a visual to stop at that point. Okay, so then I plug in 1 for all of into this equation. So I get 1. 1 times 4 is 4, minus 1 is 3. And then 2 is 5, 3 is 9, and 4 is 13. So when I go to graph this, I have over 1 and up 1, and that's a closed circle. Over 2 and up 5, 3 and up 9, 4 and up 10, 11, 12, 13. All right, so this is just going up and to the right. And it stops, it can't go to the left of 1, it has to be to the right of 1. That's a domain restriction. My domain restriction for my second one is not at 1, it's at negative 1, so I have a different wall for that one. And we start at negative 1, but if its values are to the left of negative 1, so that's negative 2, negative 3, and negative 4. It's squared. This is in vertex form, so, oops, I want to do these in a different color. Sorry about that. So I have negative 1, negative 2, negative 3, and negative 4 for this equation. So this is y equals negative 2 times x plus 3 squared plus 4. Since it's in vertex form, it's easy to get my vertex. Remember the h of my vertex, the x value, is the opposite of what's with x, so that's negative 3. And then the k is my y value. So this is my vertex, because that's the x with negative 3. I'm going to plug each of these in, and I've got negative 4, positive 2, positive 4, positive 2. And this first point is an open circle, because I do not have a line underneath my inequality. So at -1, -4, I've got an open circle that I have -2 and up 2, -3 and up 4, that's my vertex, and then -4 and up 2. So now this one's going to mirror as well. So it goes from here, it goes up and around and down, and the arrow points that way. The arrow does not point this way because it stops at that wall. Okay, next one. My first one, this is a quadratic. It's in vertex form. My domain restriction is greater than 1. So I have a wall at +1. And my first point for this equation is going to be a +1. And all the rest of the points go up from that. So I have 2, 3, and 4. There's no line underneath it, so this is going to be an open circle at my first one. It's in vertex form, so I know it's quadratic. And my vertex is going to be the opposite of what's with x, so it's +2, -4. Okay, now I'm going to plug each of these into the equation. Remember your PEMDAS, you've got to do it in order of operations. So if I plug in 1 minus 2 is -1, -1 squared before you multiply, -1 squared is 1, times 2 is 2, minus 4 is a -2, and this is a -4, -2, and 4. So if I graph this, I have 1, -2, and that's an open circle, 2, -4, 3, -2, and 4, 4. So this goes from here, it goes down, circles around the vertex, and is going up to the edge. Okay, but it doesn't go past that domain restriction. Okay, my domain restriction here is less than 0, so this time that axis is my wall. And I have a quadratic because I have a degree of 2. It's not in vertex form, so what I'm going to do is I'm going to, if use standard form and use that the x of my vertex is -b/2a. Okay, I don't have a b here because I don't have an x term. So my b is 0 over 2 times -1, and 0 over anything is just 0. So the x of my vertex is 0. If I plug that in, my y is going to be 1. So that's my vertex. Okay, as far as the numbers that I've got to plug in here, I have 0, and then everything to the left of that, so -1, -2, and -3. And this first point is also going to be an open circle. If I plug in 0, I get 1. That's my vertex. So my vertex is the beginning of it. If I plug in -1, I get 0. If I plug in -2, I get -3 and -8. So I start at 0, 1, and it's an open circle. And that's my vertex. So, and it's opening down because it's a negative. So I go -1, 0. And there would be a point here, but there's not because I can't go past that vertex. -2, -3, and -3, -8. And so this is just this side of my parabola, like that. Okay, final one. Okay, this one's got just a little bit different. Since my variable is in my exponent, I know that this is an exponential function. I know I start at -1, and all values to the right of -1, so that's going to be 0, 1, and 2. So that means I've got a firewall here at -1 that function is not going to go past. I know that I have an equal sign up here, so this first point is closed. And if I have 2 to the -1, negative exponent means we flip it and make it positive, so that's 1/2. 2 to the 0 is 1, because anything to the 0 is 1. 2 to the first is 2, and 2 squared is 4. So I have -1 and up 1/2, and it's a closed circle. 1, 0, 1, 1, 2, and 2, 4. So this is coming in like this, is going to grow. And if it went past the firewall, I'll just keep approaching my asymptote, but it stops at my firewall. Okay, because that was my domain restriction. This domain restriction also has that same wall, but it's going in the opposite direction. This is in vertex form. This is a quadratic. All my values are going to start at -1 and go to the left of that. So then I'm going to have -2, -3, and -4. I need to find my vertex. So that's easy because it's in vertex form. My x is the opposite of what's with x, so it's -2. My k is a +2. So that's my vertex. I know this first point is going to be an open circle because there's no line under the inequality. If I plug in -1, -1 plus 2 is 1. Squared is 1 times 2 is 2 plus 2 is 4. Okay, and I'm going to go ahead and work the rest of these. And 10. So I have -1 and up 4, and that's an open circle. I have -2 and up 2. I have -3 and up 4, -4 and up 10. So it goes down through my vertex, back around, and up to the other side. Okay. And that's our lesson on piecewise functions.